Got an interesting construction here of a regular hexagon, two squares on the inside, two on the outside, and we're asked to prove that PS equals YZ. Well, there's absolutely no lengths labeled. We know that some are equal, so basically this can't be to do with lengths. We have to use the angle somehow to do this proof. That's my hint if you wanted one. I'm going to first of all label PS. There we go. And also YZ. Okay, so they're the two that I'm trying to show the same. And immediately I see that I'm creating triangles here. In fact, they're necessarily going to be isosceles. These two lengths are the same. And because they're shared with the outer with the hexagon, then actually they're all in fact the same. I mean, I don't think that really matters. Actually, it might ultimately matter, but so these two are the same. Of course, I would write that down as part of my solution. I'm just explaining it verbally here. I'm going to focus on the right-hand side to start with. So I can see that I've got two squares. So these are right angles. And then the hexagon will have an interior angle of 120. It's the number of sides minus 2 times 180 divided by the number of sides. That will give 120. Or you do the exterior angle, sum divided by 6. So the exterior angles are 60 and then do 180 minus 60. Or you might just know it's just, I think you can quote it okay. So what does that mean? We've got 120, we've got 90 and 90. What it means is that this angle here will have to be 60. And then since BZY is isosceles, so if we're finding out angle BZY, then it's going to equal 180 minus 60 all over 2, because these two are going to be the same, which is also 60. Okay, I just think there needs to be enough like bit of reasoning towards it. So we've got 60 and 60, and therefore triangle BZY is actually equilateral with sides equal to. And at this point, I might, maybe I should just say that actually all of these are the same. So maybe just say the hexagon. Okay, that's good. Now let's take a look over on the left. Well, we have um, 90 degrees here, but remember we also have 120 degrees here, which is very useful because now I can write in, just trying to think of what color to use. I can write in that this angle is 30 degrees because it's going to be 120 minus 90. Of course, write that in your working. And this one here is also going to be 30 degrees. Um, and what that means actually is that I'm going to do this in blue now, this angle here, I can now compare it again with the 90-degree angle, and this must be 60. Okay, and we're on to it again. It must be that, well, we've got the triangle DSP is isosceles. So for the same reasons, angle DPS is going to equal angle DSP, and they're also going to be 60 degrees. And therefore, triangle DPS is equilateral with sides also equal to the hexagon. I mean, what we've actually shown is every single line on this whole diagram are the same length. And that means that PS, which is part of this triangle, is going to equal YZ, which is part of that triangle over there. All right, really nice question.